Hello, everyone, and welcome. My name is Dion Wiggins. I'm the CTO and co-founder of Omniscien Technologies. I'm joined today by Professor Philipp Koehn. He is in the US, and I'm in Bangkok today. We will be presenting about AI and language processing innovations and what is it good for, and some real-world use cases. Just before we start into that, I just want to introduce our platform that we're going to be showing a little bit about as we go through some of the use cases. And these use cases cover a range of options from translation in 600 languages, language combinations, transcription in 50 languages in real time, and we'll be doing a demo of that, OCR in 210 language, file conversion, NLP tools, a range of broadcasting tools, and our latest tools, which we're just getting ready to release, our generative AI tools, which we'll give you a quick demo on as well. Okay, and all of these tools, they run on-premise, 100% either on-premise or in your own self-hosted private cloud without any connection to the internet required. So we have a lot of government customers and a lot of big enterprises that need to be air-gapped for data security, and we're 100% able to do so. Okay, so with that, I'm going to pass over to Philipp to kick things off.
I thought I'd first give a bit of a grand overview of where we are, and especially the large language model space. This is like an area that has a lot of hype. So according to this chart from Gartner, we're currently at the peak of the hype cycle. And that is definitely true for claims being made, very inflated claims being made about AI, and kind of the reception in media. But it's worth pointing out that the adoption of AI in industry, so enterprise AI, is still in its infancy. And it's still not quite clear how we actually going to build all these use cases. So we're going to provide some kind of the key trends and some actually very specific use cases in this webinar to give you some idea about what all this is good for. So there has been a lot of progress as measured by these benchmarks. So this is like a list of benchmarks that were originally invented in academia. So you see them going down to like 2012, 2016 of vision and language tasks. And we've seen a massive progress as measured by what the capabilities of large language models are these days. So this led basically to people coming up with new benchmarks. So you see like the latest benchmark suddenly, like, can you solve complex math competition level problems? And even on those, we have seen a lot of progress. Next slide. I would like to point out though, like what have we actually learned? So the big moment for large language models was the release of ChatGPT now about 1.5 years ago. So where are we now? I'm always saying that it would have been nicer we would be in a position where we had a bit more clarity what the capabilities of language models are. There's still a huge gap in the assessment between the evangelists who say, artificial general intelligence is just around the corner, and the skeptics that say, well, it's just repeating the training data. So the benchmarks I just showed you, the scores are fairly questionable because we don't really know what the models are trained on. They might even be trained on the benchmarks, or at least be trained on some of the training data that goes into the benchmark. So the benchmarks usually take like Wikipedia or newspaper articles and then derive kind of tests like question answering or logical inference questions from that. But if the language model is trained on exactly this data, then of course that's a very unfair advantage. So it shows much better performance on that than on a real test of really unseen things. Even there have been a lot of studies over the last year now of just independent researchers trying things out. I don't know how many papers I've read of, oh, I tried this with ChatGPT and I can do that. And all these are really hard to really make sense of. So we're dealing with models that are black boxes that nobody really has access to outside kind of ChatGPT. And also the training data is so massive that no human can really inspect it. So when we talk about 1 trillion words, that's maybe even millions times more than you can read. So this is not something you can actually humanly inspect. Next slide. So what are they good for? So, I mean, there's a lot of anecdotal evidence of people finding really, really good use cases for them. From a personal experience, I use it for coding all the time whenever I have like some question about what's the right library to use for this, or how can you write this piece of code in a programming language I'm not very familiar with. It is fantastic for that. I also hear from a lot of people as a writing assistant, either, you just give some bullet point and let the language model generate the text for it, or take a text that's already finished written and then just say, can you polish that? People like that a lot. So you see highlights here that, yeah, improving encoding productivity is a real thing. Obviously, there's also a lot of misuse of the technology. So I'm here in academia, so I now have to confront the problem that people are cheating on their homework assignments by just kind of passing it through ChatGPT. Actually, the first homework assignment in my artificial intelligence class here at Johns Hopkins was writing an essay about like AI in literature and movies, and a good percentage of students just basically cheated according to our detection tools that you can detect if it is written by humans, so it's written by ChatGPT. There's this notorious case of even a lawyer just submitting a legal brief that was generated with ChatGPT full up with made-up cases that don't actually exist in the real world. So that's not the right way to use this. Next slide. I think big picture at the moment, I would say you should think about these models as co-pilot and not as artificial general intelligence. So using them as fully automatic systems bears many risks. So every AI system we develop has a certain error rate, and the question is always what error rate is acceptable. So, and if you build a self-driving car, even if it doesn't crash 99.9% of the time, that's still not good enough, because crashing 0.1% of the time is just not acceptable. So the bar is really, really high. And even if you have more mundane uses like, oh, let's use it for customer support, let's build a chatbot. You have here now a headline of something that happened a couple of months ago where Air Canada had to honor the refund policy that its chatbot made up. So instead of just using it as fully automatic system, it is really better to see these tools as interactive tools for translators, to people who actually know how to do their job. Just basically with this tool, they can be more productive. So these are all cases where the user can verify the responses and override it. And if things don't look, if the responses are not the way they want them, they can request again, how to produce a different response.
So when it comes to business using AI, we're seeing a lot more use of AI adoption. McKinsey did a very interesting survey that came out late 2023. More and more companies are adopting. In the survey, 55% of organizations said they were using AI, which was up from about 50% the year before and 20% in 2017. These are the areas that they're using them in. They all seem pretty mainstream. But what you have to note is that the complexity and the level of capability has changed. So while they may have been using AI in a contact center before, they wouldn't be using it at the most sophisticated levels that they're using it now. The same with customer acquisition, AI-based enhancements to products and things like that. So, things like meeting services like Zoom and Teams, for example, are now doing much more advanced features using AI. If you look at the revenues and the costs, both revenues have gone up and costs have gone down. And you can see the categories here. This is from the McKinsey survey as well. And you can see that it's quite significant. One thing that's quite interesting, though, is while the AI benefits all workers, it's disproportionately aids lower skilled workers initially. But as the AI gets more sophisticated and it improves, it's going up the value chain, and it's dealing with things that were previously unfeasible due to things like cost, return on investment, time, scale constraints. So, for example, we're going to be talking shortly about one of the use cases that addresses how thousands of hours of video was able to be transcribed, translated, and published to YouTube as subtitles for very low cost compared to doing it with human. And if they'd done it with humans, then it just simply wouldn't have been cost viable. When it comes to modern AI tools as well, they're integrating a wide variety of inputs. So, they're looking at different ways of getting data. So the traditional way people have been using it is, the AI responds to a prompt that you provide, and it gives you some information. Now, that prompt may have been with training data and data submitted with the prompt. But, that's sort of the typical way today. More sophisticated AI tools are advancing, and they're giving new ways to do things where the AI is starting to actually find information itself, and it's shifting away from even the simpler questions of what would happen if I do X to what will I know and learn if I do X, which is quite a different equation. It's capable and now beginning to consider answers from external sources. And in a moment, Philipp's going to talk about some of those external sources drying up and disappearing as copyright controls and blocks kick in. But it's able to go out and find things on the internet. It's able to talk to other AI specialists on the internet or across its own network, and then combine that with perhaps some human knowledge to find a final answer. Okay, Philip, back to you.
Yeah, just to kind of a little bit stress that last point. So this is, we are really kind of developing a very, very complicated workflow system where AI is one of the components. So you have both the extremes of pure AI and pure traditional algorithms. And then you have AI that uses, while it executes its predictions, uses calls to traditional APIs and getting responses back. But you also have traditional computer science kind of algorithms that as part of their program at some point they make calls to the AI and everything in between. So this whole chain of which task can be done by an AI, which task can be done by traditional kind of algorithmic programs, that is very complex, and it's going to be really interesting to follow where that is going. Okay, but now to another point. So going a little bit on the landscape of what is out there in language models and generative models in general. So there's a very, very strong move towards open source models. I think we're just a few days after Meta released Llama 3. So that is kind of maybe now the biggest and greatest large language models. But I was joking that a new language model is released every week. But actually, if you look at the number, in 2023, 149 foundation models were released. So it's actually more like 2 or 3 a week. So more than double than the rate of 2020, and this doesn't seem to be stopping. So that means that actually a lot of the core infrastructure, so the big component that you then, when you actually develop an actual use case, can use as a component, that a lot of them are freely available for you to use. So at this moment, the closed source solution, so GPT-4 in its most transient version, is still outperforming the open source models, but this gap is narrowing. Next slide. Just as a comment, so open source is not just the model or the code. So there's a lot of open source code available. There's a lot of open source models available, but it also means a lot of the data resources are available. Both in terms of like raw text data as kind of a big resource, customized instruction sets, and other kind of very specific data resources. So the methods of a foundation model and the methods to fine-tune them, these all exist as open source aids and allow you to advance AI by kind of coming up with customized solutions. And that's kind of the key thing and the key strength of open source solutions, that they become part of a community that uses this, finds strengths and weaknesses, fixes the weaknesses, and makes progress that way. So the development is not only done within a company that is shielded from the outside. It's done in a very open environment, and a lot of outside contributors help you to then improve this open source solution. There's a lot of education training resources available as well, and so on. Here's a bit more statistics on notable machine learning models that were released. So it is heavily dominated by the United States. partly the big AI companies, your Google, Meta, OpenAI, and so on and so on. So a lot of them are building these, but there are also a lot of startups in the United States that are building these models. There's also, interestingly, quite a few developed in China, mostly focused on Chinese language, but also throughout Europe and Canada. Next slide. A little bit of breakdown, like who develops these. So the vast majority are developed by industry, and we'll see in a second why that is. But there's also still a good number of them developed by academia and in industry academia collaboration, even by government. So there's certain governments who kind of then really spearhead the development of these large language models for their specific needs. A lot of the drive to kind of go beyond what the industry provides is also by the very English-centric focus of industry at the moment, based on that the vast majority of these models are being developed in the United States. And so then you see initiatives like even in India or China to develop these kind of language models also for languages that are more relevant for their countries. Next slide. Bit of an assessment of where we are in terms of price. So there's definitely a trade-off between having the greatest and best model versus how expensive it is. So the chart here tops out at $50 per million token, compared to the models on the left. And even, open source models are not entirely free, because you still need to kind of pay for the hardware to run it off, either by kind of contacting a provider that kind of provides a compute to you, or you buying your own machine and having to pay for that. So this is part of the larger themes that bigger models give you better performance, but that comes at a cost. Next slide. And what also plays a role in the cost is obviously training of these models. So we now pass the threshold of spending over $100 million of computing cost to build some of these models. That curve is still going up, but I'm not sure how sustainable that is. This is definitely one of the reasons why academia is being priced out of building these models, because a university, even a consortium of universities, cannot come up with $100 million to train some of these models. Next slide. So here's some of the reasons why these are so expensive. A is like the number of parameters they have, and then also amount of training data that goes into it. And maybe you come across the headline that Sam Altman, the CEO from OpenAI, apparently needs 7 trillion models to build, $7 trillion US to build the next generation of AI models over, I don't know when. So these are insane amounts of money. And this is, in a way, a very, very unsustainable trend. So what really matters when you actually want to build something that helps your business solutions. So in that case, you don't want to have a general solution that does everything. You actually have a very, very specific purpose for it. And therefore, you should probably build a more focused, customized, and smaller model. Ideally, even one that runs on your own machines, or even on end user devices, instead of on cloud infrastructures, where you have less control over the data, and they're also much more expensive than to purchase. So we're definitely seeing the trend of large language models that are tailored to specific industries, providing targeted solution for business challenges. They're customized for these contexts, so they're matched to use the vocabulary, the kind of tasks that are needed, that need to be developed. And as I already stated, there's a key thing of having it on premise, where you actually have more control over things like data privacy and compliance, and ideally even on device, where you can run it on like a separate machine that is actually the end user's machine without having expensive cloud interactions. Next slide. So the key trend here is like small language models as the next big thing in AI. So there's still a trade-off between massive models and quality on one hand, and smaller models and slightly less quality. But arguably, what matters more is how you adapt the model to your particular task than the general purpose performance of the model. So that is actually making much more of a difference. So this makes a lot more sense to think about like building smaller models. So they can compete well if you have a more focused tasks. And that really matters compared to kind of the limitations of large language models that are expensive, complex, and slow to deploy. So we see an increasingly adoption of these smaller language models due to their efficiency and so on. So an example for that is Google's small language model strategy of they have smaller, more focused models in the Gamma series that aim to enhance accessibility and functionality for everyday devices. So the future potential of that is also these are then moving out of gigantic cloud servers back to people on their own machine that allows much more democratic use of them and much better kind of use on edge devices. Okay, let me go in a little bit more technical detail on how we are able to build smaller models. So the first thing is you can build much more smaller models by just kind of using more efficient data types. So instead of storing it as floating point numbers, you can use a technique called quantization. So you use much fewer bits per parameter. So instead of using 32 bits for a float or 16 bits, you now can use 4-bit floats, 4-bit integers, because you can take the parameter space and you kind of break it up into 16 different bins. Another thing is that a lot of the fine-tuning you have to do, you don't have to do it over the entire massive parameter space of gigantic matrices. So the expensive things in these models are these gigantic matrices that multiply vectors. You can use smaller matrices with fewer parameters. That also gives you a bit more stability, that the baseline performance is maintained and only your adaptive performance improves. Next slide. Another idea is to kind of just build smaller models from scratch, but instead of just building them from the training data, which is noisy and messy, train them from the large language model as a teacher. So you have a large language model as a teacher, and then the small language model, which is, in this jargon, the student. And there are two different ways to do this. Either you take the data that is actually relevant to you, the task relevant data, and run it through the teacher model. You get the responses from the teacher model, and that is then synthetic data that you can train your student model from, or you do model distillation where you directly train the student model on the predictions of the teacher models. So the large language models, in a way, are just the starting point. So for commercial use cases, you don't need all the capabilities. You have more specialized training data, and you want to focus on that. So the idea is to build dedicated models with relevant capabilities. And for these kind of adaptation methods are the key. So so that's what we're seeing, that this kind of fine-tuning of models is becoming more and more mainstream. So the future lies in the ability for agents to serve not merely as conversational partners, but as comprehensive guides and co-pilots. And this idea of co-pilots, I think I already stressed earlier. So I want to do something. I basically want to have then a very, very dedicated solution to that. And I have a very, very specific problem. And for these, I have then very specific data sets. And getting access to these and building these models is kind of the key driver to kind of build better solutions. Next slide. I also wanted to highlight another challenge that currently is being addressed to some degree, which is the idea that These large language models make predictions, but we don't really know if we can trust them. So one of the grand challenges is these hallucinations. So today's models make plausible predictions, but not necessarily true predictions. And the user must be given some kind of opportunity to assess how true they are. So if you actually currently use Google search and put in a search term, they're going to give you a generated response, but they also give you some evidence that gives you some reason to believe that this response is accurate. Next slide. There are also interpretation methods that look at the inside of a model and figuring out when it comes to a prediction, what really caused that prediction. So they can either trace back the predictions that are being made to the input, like what was in the input and the text that was provided and the prompt that was provided that really drove that response, or what was in the training data that really influenced this response. Next slide. All these methods that give you explanations and interpretations, however, are not perfect. So the explanation is typically generated independently from the response. So the response comes out of the black box large language models, and the explanation is generated by some kind of different retrieval model that gives some kind of support for what the language model just generated. So there's no guarantee that the explanation has any reason for the response. Response was made for a completely different reason, and the explanation might be completely separate from that. It's also hard with the interpretation methods to figure out if they're actually showing the true behavior of the model. It's really hard whenever you have a method like this to say, does it actually do the right thing? Because we only know what the model should be doing, but not what the model is actually doing. That's actually the whole point of the interpretation method. I also heard the story recently from a researcher that the explanations might also create a false sense of security. So there was a use case of a medical application of generative AI where the large language model, if just provided as prediction in one case, and that's the case where the doctor was then taking that prediction about whatever assessment of a certain medical diagnosis, and the user is somewhat skeptic about it and it has some doubts and looks a little bit more thorough at it. But the moment that the large language model also provided a plausibly sounding explanation, the skepticism tended to vanish because, yeah, that now sounded right, and actually more mistakes were done when the explanation was given. Okay, final topic I want to talk about is, the AI risks in general. So here's a chart of how in different countries, how they think if AI makes them nervous, and that tops out interestingly in the English-speaking countries. And what is usually expected that the Germans are the ones that carry concerns. That's their favorite national sport. But in all these countries, there's a good number of skepticism. The main risks that are perceived are privacy. So whenever your data that is being used to build these models, can your data get revealed, or just generally having companies storing your data? That is a really, really big challenge. There's also long-standing concerns about fairness. All these models are trained on historic data, so all the biases, stereotypes, or whatever nonsense being uttered on the internet goes into training these models. So therefore, there have been a lot of proactive measures to address this. So there's at least some kind of AI legislation happening in the regions across the world. And there's also a lot of legislation and concerns about who owns the data. Can you basically tell a large language provider who caught up your emails that you wrote at some point, can you please remove that from the data? So what is the legal framework to control your data? Currently, there's a lot of concern from the people who create content that all their content gets stolen by the AI companies, and then these AI companies replace their original purpose. So here you see some statistics about how many news sites across the world are blocking OpenAI's crawler, so that OpenAI doesn't just steal all these stories and builds language models, and then becomes the news aggregator that then becomes the first source of contact to kind of get updates on new information instead of the original sources where people actually spent the time and effort to really find out that information. But then
there's a pretty stunning trend here too, Philip. I'll just point out. You know, this has all happened in a matter of months. Like you can see in January last year, almost nobody was blocking these crawlers. Now, you know, USA, 79% of media websites are blocking the crawlers. Right, so from nothing to 79% in just 1 year. Right, so the timeline here is really fast, where they've gone from not caring to caring.
Okay, yeah, that was almost everything I wanted to say. I think there's only one slide left.
Yep, last one.
That I wanted to go over. Yeah, so who's actually doing the blocking? So the sites that already kind of have monetized their content are leading the way and blocking it. So print media, broadcast media are the ones that kind of most concerned about their business disappearing, because the business consists of people actually visiting their website, looking at advertising, and that what generated the revenue. And the moment all that gets aggregated by others and then passed on, they lose the business.
Right. So I'm going to take over now, Philip. Thank you for that. I'm just going to add one last piece here. It's quite interesting that, you know, ChatGPT and the various other, you know, public variants have gathered all this data over time. But what's even more interesting is they're going to get stale. So, for example, if all these websites and you know, in such a short window start blocking live current news, like, you know, the latest stuff on US elections or what's going on in Ukraine or somewhere else in the world today, if they can no longer access this content, then they stop being an all-purpose tool. And they start being more about legacy data rather than current knowledge. And that could become a real challenge for them. But that also means that the websites that do this have the opportunity to then use large language models themselves to present their data and knowledge in different ways. So it actually might flip in terms of who's actually delivering some of the content as the language models get better. You know, they need to be able to use their own private, secure, confidential data to train the models without sharing them with ChatGPT and Google and others. But there are some concerns, of course, if you block Google from crawling you for AI, you know, some are concerned that is that going to impact my search traffic as well? And I don't think that's the case because it's a different plot, but still, you know, those are the types of concerns. Okay, so I'm going to go into the use cases now, and I'm going to go through these very, very quickly. We have a lot of other use cases. This is just a subset. If you're interested in deep diving into any of these, please drop us an email. We'd be happy to walk you through and give you live demos of many of these in production working, or more details about how you can deploy them yourselves. Okay, so the first one we all know about, we've seen many times, right? Meeting summarization, where it analyzes a meeting. But who cares about a basic meeting summarization? You need a lot more than that. Okay, so this example I'm going to give you next goes through a lot more detail. So the first thing it's going to do is it's going to analyze Microsoft Office 365 or something similar, and it's going to get pre-meeting information. Who are the attendees? What's the agenda? Those kinds of things. It's then going to process some of that information, and then you're going to record the meeting. Now, once you've recorded the meeting, the tools need to classify the meeting. So what kind of meeting was it? Was it a team meeting for software development, like Scrum or something like that? Was it a town hall meeting or a whole range of other meetings? Was it a training session? And then different workflows can be run that are specific to those meetings. And then there's generative AI that will run, and it will generate documents and maybe store it in a database or share it. So the first demo I'm going to show you today is a very simple one, and I'm going to show you classification. Okay, I'm going to show you how easy it is. So I've just logged into Language Studio, and I'm going to go down to our classifiers option on the menu. And you can see a whole range of documents here, classification heading types. And I'm going to go into one that I populated with just a bunch that I found online in terms of categories. So here you can see classifications, and I can make up as many classifications as I want. Now, all I need to train this is to simply drag and drop the documents that I'm interested in here and say, this is an example of a balance sheet. This is an example of a cash flow statement. This is an example of a death certificate. Drag and drop enough samples, it doesn't need that many, and you're ready to go. Simply press process and you have a trained classifier. Now you can do this for different meeting types and a whole range of other options as well. Okay, so I'm just going to go back to my slides now and we'll carry on. Okay, so that's the classifier here. And then we have a flow. Now I'm going to show you the flow in just a moment and the tools that we use and even the templates. So we go through our meeting, we transcribe and we diarize. Diarize means to detect who is speaking. So we're not able to just transcribe it, we're able to say it's this speaker. So then we have a transcription, but you know what? The transcription's not very clear. And that's because people don't always speak clear. And especially if they're not first language in the conversation, things like that, there might be lots of ums and ahs. So we need to clean the transcription and tidy it up. Then we need to do other analysis like pre-meeting, maybe looking at the previous meeting's notes and looking at the action items from the previous meetings. Bring all that current information in and analyze it. So here you can see in our workflow tools, this is a workflow designed for a particular type of meeting. It's got a pre-meeting analysis subroutine. It's got analyzing and generating an introduction, agenda analysis, speaker information analysis, frequency and terminology. Okay, it then runs that through and formats the outputs as JSON. And there's a custom Microsoft Word template and it mail merges in. So I'm going to show you some examples here. Okay, so here's a custom Microsoft Word template, and you can see on the template a whole range of areas that you can merge with. Now, you can lay this out any way you want, and you can write your own little routines in the workflow that can extract things out of the meeting or out of the transcription. Now, these are template rows, and it will duplicate the row, and then it will populate it. Okay, so you can see various fields and various pieces of information. So let's go and have a look at an actual resulting document. So here's our meeting, okay? Its location and all of that has been extracted from Office 365. Here's a discussion, okay, about the meeting at a high level. Here's the attendees, and here's the agenda from the previous meeting. So it's actually looked up the previous meeting in the series. Here's today's agenda, and it's going down looking at things, summarizing them, linking connected documents. Okay, it's also going down looking at discussion points that were raised, who raised it and what was the outcome. It's looking at issues and concerns raised and describing them. It's looking at action items, who's the owner and what's the timeline. Okay, it's even looking backwards at the previous meeting at their action items and what's the update. Okay, so this is just directly from a transcription. Now, that makes a huge impact when you can go to that level of detail. So it's not just summarizing, it's really going into a structured document. Now, at the end of it, it looks at the speakers as well, and it can do things like speaker statistics. It's saying this person filled these roles. Okay, this is what they talked about. Here's their total interactions. They were professional and so on. But what I really like is this simple one at the end, terminology. Here's all the special terms that we talked about in the meeting. And in this case, SIM doesn't mean SIM card, right, like your cell phone. It means a security information and event management item. So those are the kinds of things there that it can look at. Okay, and I'm just going to go on to one other key point. So you'll see the cleanup. So here you can see somebody who's saying quite a few ums and ahs, and it restructures the content to be more readable. But also speech recognition is not sort of perfect in its boundaries. Often because I pause, I'll say, okay, thanks. It's not as fluent, okay? Or perhaps there's a pause here, and you can see it restructures it to be a much more fluent sentence. And this is very good for other things as well, such as generating subtitles for real time and all these kinds of things. Okay, so with that, let's look at generating subtitles in real time and translating and show you what we're doing for a project at the moment. So we have video transcription and translation. Now, this content was interesting content. It was very old. It's 20 plus years, and it's been given a new life. It's got a lot of episodes. It was a very popular set of soap operas, and that was carried through from one language to another. So what we did was we pick up the files from the customer, we check what they are, we convert them, we do the speech recognition, we analyze the scoring, okay? We fine-tune the content using a large language model. So we're looking for problems and fluency and things like that, and we fine-tune it. Now, both the speech recognition and the large language model have been adjusted to the customer's data specifically for this purpose. We then look at the scores and we decide if we need a human review or not. If it's above a certain quality, we then translate it to English and we fine-tune again. And that fine-tuning really helps. It's using both German and English, and it's taking something that wouldn't sound so natural in English and making sure it sounds smooth. So as an example, one of the examples was they said, oh, these two people are polar opposites to each other. And it changed it to a more general sort of daily dialogue of these people are like chalk and cheese. So it picked up the idiom, and then it publishes straight to YouTube. So a lot of the content is going straight through without a human touch. Okay, now this would not have been viable using humans only. It would have cost many, many multiples more than doing this task. But the key was a combination of customized technologies, customized speech recognition, customized language model refinement, customized translation, and customized language model refinement again. Okay, and there's a process of circular data going around and training. Now you can see in our data outputs that we have confidence scores and a range of other things that are measured for quality. And this is how we can handle this and determine if a human needs to get involved or it can go all the way through without a human touch. Okay, let's look at another example. And again, I apologize, I'm going through very quickly because these are just very high level to give people some context. This is human resources in this case, but it could be any kind of document. It could be a director's script in a movie. It could be lawyers' contracts. It could be an RFP where you've got 20 RFPs coming in. Okay, so here's the basic use case. We're going to do HR this time. So emails arrive, you put out a job and you get 200 resumes coming in. It'll detect the language, convert it to English, classify the resume into maybe a particular set of formats. Then it will do a specialized flow to extract and normalize the resume. Okay, so we're talking something like this, converting it all to a standard format for easy reading, looking at the things that you're interested in, not that they want to tell you, okay, and then storing it in a database or a spreadsheet or a JSON or XML structure, plus a Microsoft Word document that has been standardized and normalized. Okay, now this could be done with a contract. You could be saying, right, what's the term, what's the jurisdiction, what's the general items of the contract, what's the various other elements, summarizing the key points, summarizing who the signatories are, and various other pieces that you're interested in. Okay, let's move on to e-discovery, one of the more simple ones, but also one of the more powerful ones. So law firms often get hundreds of thousands or even millions of documents. They literally get buried in documents. Okay, they have tools to find them, but a lot of law firms aren't very good at doing things that are international. So I remember a few years back, we had a project where Samsung and Apple had a lawsuit, and there was about 10 million emails that had to be analyzed. But of course, they were all in Korean. So we were able to translate those and then process them. Now, if we were doing it today, we'd be using things such as the connectors that we have with Relativity and through one of our partners that specializes in this area. And then we'd be generating metadata about what the contract covers or what the document or emails cover, and maybe summarizing it in 1 or 2 paragraphs so that you can see it and then pull it out. Also extracting key terminology, important names and information like that. Now we customize at a very quick level, and I'll talk about customization in a little while, and then we come back and deal with all the other pieces. Now, if we go one step further, this is for one of our government customers, okay, and they have a legal raid where they've raided a company that's done something bad. They've seized hard drives. We inventory the hard drive very quickly, analyze all the languages, then prioritize based on language, data type, file type, etc. Image classification, is it a picture or a scan of a picture with a document? OCR, object detection, detailed language ID, audio language ID, all sorts of general things. And then more specialized document classification using the classifiers that you saw earlier. And then we can start to ask it things like extract emails or messages that discuss financial matters, tax planning, or tax avoidance strategies. So all of these are the kinds of questions that you can answer. Now, I'm not going to read them out, obviously. This presentation has got a lot of detail. It's intended for reviewing later if you want to dig into more detail. I've got too many use cases to actually spend too much time on each one today, but I'm happy to present them to you if you're interested in more detail. Okay, one of the other areas gets really interesting is audio analysis. So here we have a security camera with a radio blasting, and we have two ladies yelling at each other, arguing, and I guess the guy could be saying, calm down, take it easy, calm down, but these two ladies are overlapping. And this is all on a regular audio channel. We're able to split these people off into separate audio channels and then straight away be able to do speech recognition more clearly. And we're also able to turn the radio off completely. Okay, we have monitored processing. I'm just going to show you a couple of use cases here. We can monitor folders and monitor email boxes. So here, imagine you're an international company and you get invoices from around the world. And let's say, just for a change, your language is not English. Let's say it's German. So your finance team, small team of, let's say, 3 or 4 people, they're struggling to handle all the different language invoices that aren't German. And maybe their English isn't their first language, they're not super strong. So you mail to accounts@abc.com. It checks the mailbox periodically. It detects the language. It converts it to English or German or whatever language you prefer. It automatically extracts data. And that would, again, be a custom model that's designed to process invoices. And it would find the purchase order number, match it to the database, and possibly even go further and cross-reference the elements. Okay, same sort of thing here, but much more simple. An email comes in and it's not in your language. You forward it to translate to English or translate to whatever language at mydomain.com. It will detect the language, convert it to your language, including all the attachments, and mail it straight back to you in about a minute. Okay, we can do the same thing with a folder. And earlier you saw the flows. So we can classify documents and run any kind of flow that you want. Translate, analyze, run multiple different workflows, send emails, file and store. All these workflows are very, very flexible. Okay, this is one of our new features that'll be released in our next release, where we can translate anything to a given language. So again, I'm using English in this case. So you get documents come in and they have more than one language in them. So here's the biggest language document I've seen to date. It's got 45 languages in a single email. Now, this is an email sent to lawyers that gives them a daily update on legislation and policy changes globally, but each country's data is in their own language. So in just a few seconds, this converts the entire email to English and all the articles that it links to if you need to see them. Okay, so all of that content, Indonesian, Irish, which is English in this case, Italian, Japanese, and the rest of the 45 languages straight through. Okay, this is where things get quite interesting. Live agent assistant. So we've all seen things like, chat bots and things like that, but let's go a step further. So we'll start at a basic level. So let's say we're using Live Person, which we've already been integrated with some of our customers. So they start talking backwards and forwards in chat. There's an agent who can check the response, or if you're bold, and it depends what you're selling and what you're working with, maybe you don't need the agent. You can take the agent out of the loop. Okay, and it can go backwards and forwards in real time. Okay, so here's a simple example where the customer complains that he wasn't paid properly making a bet. Okay, the agent automatically asks, what was your transaction number? Okay, at that point, it looks up the data automatically in the database, brings it back, and then passes over to a human agent to check the answer before it goes out. And then it can finally go back. But a lot of the task is automatically taken care of. But let's go one step further. Let's look at agents as a whole in call centers. What about analyzing their success, their failures, and how they're interacting with people? So being able to deal with those kinds of things, giving the agent feedback in real time is great, but what about giving management feedback? So things like interacting with the customers, that's great, but tying that through what works, what doesn't, training, all these kinds of things. So having these automated responses and guidance, these sidekicks helps you with training because you can see a lot better answers straight away. You don't need to sort of every now and then spot check somebody. You can check every single interaction with every single customer and make sure it goes smooth and actually work out what's working, what's not, and guide the agents to the best answers and best solutions. Now we're going to go to the translation industry. This one is a little bit contentious, but I'm hearing the same thing in AI spaces now that we originally heard when we first started machine translation 16, 17 years ago, and we were told, oh, I don't want to use machine translation. A machine can never do what I do. I'm creative. Okay. Or, I spend more time doing this. I don't want the machine, those kinds of things. Now, most of those things have gone away now and things are getting better. But we have the original use for the transformer models, right? It was originally built for neural machine translation by Google. Now it's been evolved into things like ChatGPT. We have automated post editing, which is sort of in the middle of its maturity phases. It's still got some way to go. Glossary enforcement is new. So actually analyzing using language models and making sure that neural machine translation has applied the glossary correctly. And if it hasn't, adjusting and fine-tuning it. Quality estimation, it's getting there. It's getting better all the time, but it's not perfect. And style adaptation, these two are in their infancy. So we're working on all of these, and we'll have tools coming out in the space very soon. And we're seeing some great results from things like glossary enforcement, quality estimation, and style adaptation. Now, when you customize models, you want them to be an expert. So we have the general models, and then we have deeper skills that we train. Now, when we train a model, it can have anywhere from a few hundred million to billions of sentences. But today, in many cases, we're synthesizing as much as 500 million sentences for customers. Okay, so we do a whole range of processes. We don't just do the upload and pray approach. We take data and we build new data from it. Okay, now when it comes to stylizing, previously we used to create training data, but we've been working on new tools now that we'll be releasing soon that actually stylize content dynamically. So you can have a standard engine and then adapt the style to make it more Mercedes-like or more Honda-like or so on. We use large language models and other NLP tools to extract information. So here's an example, cold shutdown. And here you can see it generating content to create training data for both speech recognition and for translation. Now, this is not just monolingual, this is bilingual too, but we start with content often from the customer. So here's an example that I just pulled from the web recently and thought, okay, I'll use some content from Mercedes-Benz that's online, and I will seed that, use that for seeding, and I'll generate this other content that I can now use for speech recognition guidance or machine translation. And these are all on-prem in your office LLMs. So we do this in-house. We don't use ChatGPT or anything like that. These are all our own fine-tuned custom LLMs. Okay, we can also do this bilingually. So here you can see some very good examples of English and German to create synthetic training data just by using terminology. So here's the German term, here's the English term, create the data and actually learn from that data dynamically. And we're creating up to 500 million sentences using this technique. But you'll notice here it's not just sentences, it's also paragraphs. And this is because we're training engines in many cases in document mode. Okay, we can also pull content down and automatically match pages from a website, and then match paragraphs and then match sentences together, all done with AI. So there's a whole range of areas here. Now, when it comes to automated quality estimation, okay, you can see the types of quality. It's not just scores, it's also guiding the linguists. Okay, now we're going to run over time by about 5 minutes today, I'm afraid, folks, and then we'll have our Q&A at the end if you want to stay on after the full hour. Okay, so I'm just going to carry on quickly here. So you've got here examples where it's looking at vocabulary and saying this sentence is fluent, although this phrase is slightly formal. Or this is a bit strong, you might want to soften it to something like this. And here's the adjusted version that we could recommend, and you can accept it or reject it. Or you can take guidance from it as it goes. Okay, now a few years back now, 2 years back I think it was, Translated put out a set of survey results. They've been tracking editing effort for a number of years, since 2015, and you can see it tanking. You can see it's very interesting to watch the content and how quickly it's being improved over time. So time to edit is a really important metric. It's not about how many edits, it's about how fast you can fix it. And that is the most important metrics. Now, this was done over 2 billion sentences and 136,000 top translators. And it changed things. Now, TransPerfect jumped on the machine translation bandwagon a few years back, and that really changed the market. One of the companies we interviewed a little while back, they had a massive change in market. They took their revenue and it changed completely. Deal size dropped, but they were impacted by TransPerfect significantly. But they've recovered, they've turned it around, and now they're closing twice as many deals, but at a lower overall revenue, but overall things are going up. They're also already 80% doing QC, and 20% of content is seen by human. Okay, 100% of content is QC. They couldn't normally do. So this is the old sort of traditional MT flow. Document, translate it, here's your output, right? Maybe, for argument's sake, let's say 50% is less time than human only, so you have some gain. As it evolves, you start doing automated post-editing. That reduces the percentage down and changes movement a bit. Then you continue to evolve. The numbers go up. So you're now 80% less time than human only. Then you start to look at quality estimation, and you can decide, okay, I'm going to bypass the post editor on this much content and only send the stuff that I'm not confident on to the post editor. So suddenly you've taken out that human editor, but you still have human QC. Then you can start to move as trust is built down the line so that actually even the QC from human can be bypassed in many cases. Now we're heading towards that level now. Not many people have that much data and that much content, but it's getting there. There's a couple of people dropping off because I'm slightly over time. There will be a replay that will carry on with the last tail part of this if you want to see it. Finally, we can start fine-tuning and automating the process even more over time. Okay, and this is my very last use case today. Okay, so bulk media. Now, we had a project we were looking at doing some time back. It ultimately didn't go ahead for a number of reasons. The project didn't get funding, but it was about National Archive for an entire country with over 100 years of content. Most of it was analog. And so getting that content in, digitized and processed was no small feat. Okay, so we went through and we built a plan to enhance video quality, automatically analyze scene changes, facial recognition, object detection, generating a range of metadata, audio detection, language detection, speech separation, as you saw earlier, voice print analysis, all of these tools, and driving it through with little to no human. over time, there would have been human on the valuable content, but a lot of the content may not have been valuable. We have to be careful here of where we spend our human effort to improve it. Okay, so I'm now going to open up for questions. But before I do, I'm just going to jump over to Language Studio again and give you one final demo of a couple of our tools. Okay, so earlier I gave you an example of classifiers. I'm going to go to generative AI, and I'm going to show you a couple of the features. So we have our classifiers, we have our models, and you can download models from Hugging Face and many other places. You have your prompt libraries and you have your workflows. So if I go to workflows, and you'll see here an example of a workflow that I'm just going to give you a very quick demo of. And it says, okay, here is my content. So I have a conversation buffer. I have a customized language model, Llama 2. Okay, I have a prompt template, an LM chain, and a text-to-speech converter. That's our workflow. Okay, now this content has been trained on content from Egypt. Now I'm going to go into here, and we have 3 tools here that we can run. One is Ask Your Documents, and you can upload a whole bunch of documents and just start having conversations with them, right, in real time. Generative AI chat and batch runner, where you can run thousands of prompts one after the other. So I'm just going to go to our generative AI chat. Okay, and I'm going to pick my option here. So this is my workflow. Okay, and I'm going to go to speech recognition, and I'm going to turn my microphone onto the correct one. And this will take 10 or 15 seconds to start. Okay, should be there in just a moment. Okay, hello, great Pharaoh. I'm going to ask you some questions about your family and your history. I'd like to understand more about your family. Can you tell me about your family lineage and how it changed the history of Egypt? I'd be really interested in understanding. Okay, and we're going to send that.
I inherited the throne from my father, part of a divine lineage governing our lands for generations. This sacred lineage, upheld through practices like intra-family marriage, was essential for preserving our...
So that's the type of thing that we can do in near real time, and you can see it here transcribing as I'm still speaking. And we can produce this very quickly, very, very accurately. Now, this was trained on a large number of documents about Egyptian history, and it's able to answer these questions in real time. This is the type of features that we can build into the workflow, and we can tie it together. Okay, so with that, I'm going to open up to questions. Does anybody have any questions today? Okay, somebody's asking how much. That's the first question. All right, well, obviously, without scope, I can't give you an outright answer. But if you have some ideas, drop me an email, dion.wiggins@omniscien.com or sales@omniscien.com for my team. And I'm happy to discuss and provide as much detail as you need. Okay, does your quality estimation work on single sentence, or is it able to handle a chunk of text in a paragraph? The answer is both. Okay, it can work on individual sentences. It does not need a reference translation, although reference translations often help. Here's a good one. What languages are your LLMs? That's a really good question. So we can train different languages, but we can also pull down existing models that are very good. So Philip talked about foundation models. Now, we can't afford to spend, $100 million like ChatGPT or $1 billion plus like Google is. So we take the foundation models that are most appropriate and we fine tune them with large amounts of data. Often we create synthetic data to do that. Okay. Do you still use NMT? Okay, absolutely we use NMT. Large language models are not perfect for everything. And Philip, you might want to jump in on that one a little bit.
Yeah, that's also in the theme what we said earlier, that smaller focused models are often then much cheaper to build and maintain. I mean, this is also, you don't want to have like the biggest thing that is then really, really expensive at inference time, when you can get the same performance or even better performance, especially when you customize it with a much smaller model.
Right. I'll add something to that as well. So, if you have a bilingual speaker, let's say Philip's bilingual in English and German. So, and he could translate most things very, very well. But if I ask Philip to translate an article on neurosurgery, he knows nothing about neurosurgery, so he would struggle. And this is where creating these smaller vertical experts becomes really important. So you don't want necessarily everything in one model. And in fact, in a workflow, you might have multiple models of different origins. So you might have one built on Llama 3, another one built on Mistral, all talking and engaging with each other as part of a single workflow. And that leads me to the next question on here. Once trained on the Egypt documents, is it stored for the next projects? No, each model is customized for purpose. Okay, we don't want to be everything for anyone. You want smaller, focused models. So if I'm doing invoicing analysis, I don't really care about Egyptian history. So we keep them completely separate. And when we train for a customer, these are all done specific for a customer, and our tools are now moving to training in the customer's office so that we don't even need to see the data. Are there any good Japanese models? I haven't tried with Japanese much yet. We have a little bit of stuff we've done with Japanese, but I couldn't really tell you with absolute certainty for LLM. But I'm sure there are some building. I think that's a really key point, that the actual models coming out now are being fine-tuned with multilingual data, and you'll see a lot of language service providers loading their multilingual data into other models, such as a Japanese model, and fine-tuning that, or creating synthetic models on top of that. Okay. So I'm getting a couple more model questions that are about the same sort of topics. Are there good models for Nordics? Again, there are companies and organizations doing things like that. And there's some new techniques coming out about model merging, which we tried it. We weren't successful initially, but we're watching it closely, where we might be able to take, let's say, an expert Nordic model and merge it with an expert Japanese model that's built on the same technology and the same foundation model. Okay, have you experimented with language adaptation, i.e. Chinese Taiwanese or Chinese to Taiwanese, or UK English to US English? Philip, do you want to try that one?
Yeah, we have explored that like a few times. So it's basically very similar to kind of style adaptation, also that the vast majority of the text doesn't get changed, but like the certain words, jargon, expressions, and so on changes. So this is we use very similar techniques as we do for adapting to a particular style, like financial documents versus more casual kind of sports reports and so on.
So while Philip was talking, I just went and grabbed a bunch of text and I changed the flow. Now I'm just going to run this content that I just copied and pasted, and I'm going to say rewrite in the style of a sales team for plastic. Okay, so we're changing an article that's negative about the content, and we're rewriting it. Now, this is nothing special, but this is the type of thing that large language models are capable of doing. Now, if I was to say change to British English, and you'll see it change the spelling and maybe a bit of the sentence structure in a few places and so on. Okay, so This can all be trained in, and it could be French and Canadian French, or Mexican Spanish and Colombian Spanish. But going from simplified Chinese to traditional Chinese, or from something like mainland Chinese to Taiwan Chinese. Okay, there are subtle differences. I mean, first of all, you've got simplified and traditional writing, but you've actually got different vocabulary. So even though Hong Kong and Taiwan, for example, write using traditional Chinese, okay, they have different ways of saying things, and these two can be adapted. Okay, let's see for a couple more questions before we wrap up. Regarding data privacy, where is your data center and hosting for the secure cloud? So our data center is AWS. It's in Europe, okay, and it runs there. However, we're moving very rapidly towards training in the customer's own environments, where we will give you the tools where you can quite literally take your data. You can go here, you can drag and drop your files, and you can train your own models directly so that we don't have to get involved. And this will spin up an AWS instance or a Google Cloud or Azure instance, train, and then shut it down again. Okay, so all you need is an account there to be able to do that. Okay, so these are private servers. Okay, and this is the strongest way that you're going to get data privacy, and it's also going to give you the best results because you have your own sensitive data that you wouldn't want perhaps to release to us. Okay, a recognized ethical issue with LLMs is the energy required to train new models, which is better. Okay, I think, Philip, we've had some discussions on this in the past, and the bottom line is, you've already got the big models, but training a small model can take sometimes just minutes. So we're not actually talking about that much. What do you think on this one, Philip?
Yeah. So I mean, the big computation costs, that the ones that people spend tens of $millions on and requires insane amount of compute, that is done to build these foundation models. Yeah, I don't know what to say to that, except people keep doing that. Yeah, we are mainly in the business of kind of taking these models and adapting a particular purpose, which we try to do as computer efficient as possible.
Right. Okay, so I think we probably have to wrap up at this point. If anyone has any additional questions that they'd like us to address, please drop us an email. Just send it to sales@omniscien.com and we'll send you a reply. If you'd like a live demo with more information and more detail on any of the use cases and things like that, drop us an email as well. We're happy to set up a live demo. I hope these use cases were helpful for you. They're intended to just show you concepts. Obviously, there's a lot more to them, and we're happy to do a much bigger deep dive if anyone's interested. Okay, so thank you for your time, and we look forward to seeing you in the next meeting. Thanks, everyone. Bye-bye for now.